Welcome to the video that I've put together to try to go through the installation and assembly of this extrusion-based plotting machine. What you're going to be able to see is pretty much the full assembly process. The only things that have been skipped are preparation of the holes for the machine screws that you're going to be seeing put in place. As a result of the fact that this is pretty much a complete assembly, it's quite a long video. So big apologies for anybody who feels the need to go all the way through to the end. I compressed it as much as I felt I could while still keeping all of the major steps in place. What you're going to see is that many of the assembly processes have been sped up in the middle by a large amount so that you see the start and the end of the operation, but you perhaps don't see me just for hours and hours on the time screwing in lots of little M3 machine screws. On that topic, nearly all of the holes that have the machine screws in place like this have been prepared already by reaming to 2.5mm and then tapping to accept the M3 machine screws. The tap that you use isn't particularly important, it is just plastic. As a result, it doesn't need to be particularly high quality, but as an approach it does seem to be fairly robust. I've used probably more screws than I need to in order to hold things together, and it seems to be robust enough to keep things going without too many problems. This part you've been watching is one of two end mounts for the main rail. This is a 20x40 V-slot extrusion, and it goes into the hole that you can see on the end there and is clamped in place by those 6 screws. This is the belt clamp end for the single continuous belt. The 4 screws you can see there, 2 per side, are the screws that actually clamp the belt in place, and the other 4 that you can see are the ones that hold this end of the arm. So the 20x20 arm goes over the top. Moving to the other end of the 20x20 arm, this is the pen lift assembly. The short V-slot rail you can see here gets clamped into that holder with a couple of machine screws. That's to allow a little bit of adjustment for the position. The 2 screws that you can see me assembling here with washers are fitted loosely to allow the servo for pen lift to be fitted later. Here is the other part of the pen lift bracket. Again, there's a couple of screws per side that go in to clamp it onto the extrusion, but the next part you're going to see with some washers for spacing is the main return roller. It's a smooth roller for the GT2 6mm belt that I've used throughout, and this will allow the return roller to spin freely. And that's one of the things that you're going to see, is that nearly all of these pulleys have to have their the fitting of the screw adjusted so that they spin freely and there's not too much clamping on the bearings. The pen lift has to get fitted to the end of the arm. At this point I realised that I'd actually done things out of order, just in case you weren't sure whether I was recording this live. So I now am able to fit the second screw in place to hold this onto the end of the arm fitting and reinsert the extrusion into its slot. Installations completed. This is possibly the most complex part of the assembly. You can see I've already got 3 pulleys installed. There's a single washer for spacing to make sure that they don't bind against the inside of the printed part. These are the main pulleys that allow the belt to pass through this center part of the machine. When these are being installed, it's important to make sure that they're not so tight as to start preventing the pulleys from spinning freely. And what you can see on the table in front of the part is the M3 nut, which is used to clamp the bolt down so that it can be held in place without causing too much tension on the bearings of the pulleys. There isn't a lot of thread sticking out. In reality, the bolt is probably slightly too short, but it seems to be effective, and it had been installed that way for a very long time, so I think it's okay. This is the upper part of the central assembly, and you can see here, just double checking that all of the pulleys are actually spinning freely enough. This is the lower part of the central assembly. Each of these two pairs of the main bolts, they have these screws attached so that they can be adjusted. This is important to make sure that the belt is appropriately clamped. Having put the adjustment screws in place, now all 8 of the larger bolts that hold the main V-rollers can be inserted. As you can see here, 4 per side, 2 for the main rail and 2 for the arm. Once that's done, every bolt needs a spacer. These are printed spacers in this case because I didn't get any metal spacers with the V-rollers, and then the V-rollers get put in place. And then on top of each V-roller there's another spacer. The printed spacers are basically there just to make sure that the core of the bearings doesn't rub and bind against the other printed part that goes on top. This is the top part that we just saw being assembled. This is one of the tricky parts of the assembly. Unfortunately, there's no very easy way to install this. It is a process of just gradually wiggling all of the parts together until things fit. Once the 4 in the outer edge are installed and the part is relatively square, it's usually going to be possible to give it a rattle and also use the screw threads to pull things together a little bit more. Once those are all in place, next step is to have a look at the top and install the nuts and washers that will hold this part together. These bolts are important because they do hold the central part of the machine together, and they not only keep it square, but they also stop it from rattling. Lock nuts are used because they need to have some tension, but you shouldn't be clamping down on them hard. So with the lock nuts, it's possible just to get a little bit of tension to hold things together, but not really clamping down on things so the bearings stop moving within the V-rollers. After I install each of the nuts, I'm just giving all of the bearings in the V-rollers just a little bit of a spin to make sure that things are working properly. None of these need to be particularly tightened at this stage. In particular for the bolts that need the adjustment screws attached, it's important not to clamp down on them too hard. Next step is the pen lift assembly. This is formed using the printed part, but also these additional V-rollers. These ones came with metal spacers, which was quite nice. I used to have a different design of pen lift which didn't work as well as this, so these were bought in a separate batch from the first lot, and they happen to come with metal spacers. Once they're all installed, again it's a question of making sure that they spin freely so that you can have the pen lift fall smoothly under its own weight. This screw is the part that allows the servo for the pen lift to lift it up. It's just to prevent it from potentially scratching against the wheel. This screw is the one that allows you to adjust the clamping force on the pen lift. The outer part, the fork, is reamed out to M3 because the screw thread shouldn't be biting into that, and the inner part is reamed to M2.5 and tapped for M3. Also here, you couldn't see it very clearly, and unfortunately I didn't really let you along, although I'm demonstrating it here. There are two sets of holes on the pen lift for the pen holder. One of them holds the pen vertically, as you can see here, which is good for technical pens and many other types of pens, but there is also a set of 45-degree holes. They allow you to use fountain pens or any other pens that perhaps don't want to be held completely vertically. This screw is the one that clamps the pen in place. The pen lift assembly can now be put together. As you can see here, it's having to slide down the V-rollers down the V-slot extrusion. It is important that the tension on the rollers is set to allow it to fall under its own weight. But do remember that it will actually have a pen in there as well, which will make it slightly heavier. The rails get put into place, and you can check that things are moving smoothly. The end mounts get clamped into place. At this point we're putting in the upper arm. Again, that fits through, and you can see the adjustment space allowing the bolts there to rattle as it was installed. That slack will be taken up with the adjustment screws a bit later on, and there are two adjustment screws for two of each of the four bolts that hold one of the arms in place. The pen end of the arm is clamped in place now, and you can see that things still fit. This is adjusting the clamping force on the pen arm. I'm just checking to make sure that it doesn't rattle around, and then doing the same thing for the main arm as well. It still moves smoothly, but it's also important to make sure that it's not allowing any rattle from side to side. Balancing that tension is fairly important for getting good quality drawings. The belt clamp arm gets put into place. Now we can install the stepper mount on the other end of the main rail. The main plotter is getting installed onto the body of the board that I've used. This is an old chipboard shelf, so I used some wood screws for that, but you could bolt it through if that was something that you needed. You can just about see there the control board as well. The control board has wiring which goes out to each of the stepper motors on either end of the main rail, but also has a set of wires that go out to the pen lift servo. You can see here I didn't choose a particularly clever routing for the cable, and I later reinstalled it in the correct place because that routing was a little bit awkward and got in the way of the carriage slightly at one end of its travel. The cable management that you can see here is basically allowing the servo cable to be kept out of the way. There are many different options for how you might want to do that. I actually had some stiff tubing that I used to keep everything clear. If you have something else available, by all means you can use that. There are mounting holes in the end and on the central part. This one here you can see is on the pen lift, and again it's just allowing the servo to be mounted with its cable out of the way so it doesn't bind up in things. Mounting the servo, it's important to note that these bolts you can see are not going through the holes in the servo, they're going kind of into the end. I didn't have enough plastic available to get the bolts all the way through, so the washers and the bolts together are holding the servo in place, but they're not going through the servo holes. This next part is one of the slightly fiddly parts. What you can see here is the threading of the belt, and it's a continuous belt all the way through the machine. It's clamped in at the end, and then it comes out into the central part. You can see that I've had to use needle nose tweezers to grab a hold of the belt here. You'll see it from another angle later, but what is happening is that I'm pushing the end of the belt into the tweezers to allow the belt to be drawn through that really quite probably too small hole there. That's pulled through, and then it gets wrapped around one of the drive pulleys that's bolted onto the shaft of the stepper motor, and then the belt gets taken back into the center of the machine again through one of the other holes, pulled out through the center, and then comes out through the other hole 90 degrees away. Next step is to take the belt around the main return roller at the pen lift end. Gets taken back to the center for another trip through the pulleys. And again you can see that I've got the needle nose tweezers put in place to allow the belt to be extracted. This is the other angle I talked about earlier, where you can see what I'm doing is just allowing the belt to go sideways into the end of the tweezers just enough to grab it, and then it can be drawn through the hole gently to go out to the second drive pulley. As earlier, around the stepper, and you can see a better view of the control board there. This is a clone of the iBot board that's used for the Evil Mad Science Eggbot machine. It's an extremely good board, and I do recommend it if you want to use this kind of drawing machine. The belt then gets taken through the belt clamp, and we're now ready to tension the belt. With one end clamped down, it's possible to pull simply manually is enough onto the belt in order to get it tight enough that the machine can be operated with precision, but not so tightly that it binds up. And here you can hear that the machine is moving, and you can feel that it's all clamped together and it's reasonably intact. At this point, it's basically over to watching the machine draw things. What you're going to see now is the machine drawing its own project poster. The project poster is a vector drawing that gives you some details on the parts that you're going to need and any other things. As you can see here, it is a Creative Commons licensed project, so you're very welcome to use it according to the terms of that license, including attribution and making sure that you're passing on the files if you feel that you want to modify them. The assembly details are all included. Obviously this is very substantially sped up from actual. These parts are taken from CAD, which is all in OpenSCAD. OpenSCAD or OpenSCAD is set up in this case to be a parametric model, but I would advise you not to rely on the parametrics. If you want to change the dimensions substantially, it is very likely that some of the parts might not work exactly as you might hope. And that's really it. Apologies for the length of the video. Hopefully someone manages to make it this far. If so, thank you very much. You have my gratitude. Hopefully this is useful if you want to make a drawing machine like this. If you're interested in more videos like this, I'd love to tell you that there will be more coming, but in reality I'm not 100% sure as and when that will be the case. But I do at least hope to put some more of my projects in this project poster format so that you have the video to refer to and you have something which you can print or plot to let you see what's going on. Thank you very, very much.